So here's a question on solving simultaneous equations using two methods, substitution and elimination. Here is our system of equations. Let's start by labeling the two equations. I'll call this equation 1 and I'll call this equation 2. Let's solve this first by substitution. So let's copy the equations. Okay, so here we have an option to solve for a variable in either of the equations. So we can solve for x for the first equation, or solve for y, or y on the second, or x on the second equation. It looks like it's easier to solve this by looking for the value of x in the second equation, so that there won't be too many steps that we need to make. So let's solve for x in the second equation, which means we need to isolate x on the left side of the equation. So let's copy that. Let's move x on this side of the equation, and let's move 5 on that side of the equation. It is the same as when you add x here and when you subtract 5. So let's say add x here, and when you add 5 on both sides of the equation. Okay, so which will give you x on this side, and here we've got 3y plus 5. So our x is 3y plus 5. Let's just rewrite it one more time. Or if you like the x on this side, you could do so as well. Let's call this equation 3. Now from equation 3, we've got the x. We will be replacing the x on the first equation becoming this value of x. So let's write here, substitute x equals 3y plus 5 in equation number 1. So copying equation number 1, let's make the x 3y plus 5 is equal to this value plus 36. And then from here, we will simplify the left side of the equation, and we will just solve for y. As you can see, now we only have one variable which we can solve for it. So distributing 3 to 3y plus 5, you have 9y plus 15 equals negative 12y plus 36. Let's add 12y here and add 12y on this side, and let's also subtract 15 and subtract 15 so that we could just isolate the y on the left side of the equation and the constants on the right side of the equation. This would be 21y, this is 0, this would be 0, and this would be 36 minus 15 is 21. Let's divide both sides by 21 so we could solve for y. So y is equal to 1. Okay. Now after we got the y equals 1, we can substitute this either on the third equation because we set that up already, which came from equation number 2, or you could still have a choice to substitute it in either the first or the second equation. I will just use this x value here. So from equation number 3, so we got, let's write it down. So we'll write our step. Say substitute y equals 1 in x equal 3y plus 5 to solve for x and solve for x. So we got x equals 3 times that value of y plus 5, which is y is 1. And we just need to simplify this. This is 3 plus 5. Our x is equal to 8. So here it's clear that our solution is 8, 1. So let's write it up here. Solution is 8, 1. So meaning our x is 8 and our y is equal to 1. You could continue your work by checking the solution by substituting the x and y value in either one or both of these equations. So check. Let's choose equation number 1. This would be 3 times that x equals negative 12 times the y plus 36. So our x is 8, our y is 1. Simplify. This is 24 equals 12, negative 12 plus 36. 24 is really equal to 24. Let's check with equation number 2. Let's copy equation number 2 once more. So that's 3 times the y minus the x, which is 8, equals negative 5. So y is 1. Be careful with checking. Make sure you're writing the correct value. So this is minus x, which is 8. Now we've got 3 minus 8 equals negative 5. So negative 5 equals negative 5. So we have just verified that our solution is definitely 8, 1.